Dear students, today we will continue. This is our online lecture 6. We will, in this part, cover the remaining part of what is mentioned on this slide. Remember, we mentioned before, we talked about the factor-factor relationship, which is the case of having two variable inputs producing one output only. And in this context, we defined what is known as the isoquant. It is a curve, as we said before, that looks like the indifference curve, but talks about the relationship between two variable inputs producing the same level of output. And we said that we can produce the same level of output using different levels of the two variable inputs, okay? Which means that the two variable inputs x1 and x2 can substitute each other. We also defined what is known as the isocost line, and we said it is similar to the budget line of the consumption theory, and it is the line that shows all the combinations of x1 and x2 that results in the individual producer pays the same amount of cost. In the end, remember we defined this production function right here. In this case, we have two variable inputs. As you can see here, we have these two variable inputs here, and then after that, we define this is the case where this is the equation that defines the isoquant, and the reason we are having y bar here to indicate that we have the same level of output, fixed level of outputs. And function of x1 and x2, it means that when the levels of x1 and x2 changes, we still can produce the same level of output, and that's why it's called the isoquant, equal amount of production. This is the curve, how it looks like. Remember, we have first a variable input, labor and capital, and then these are different combinations that could be produced by using different level, the same level of output that could be produced by using different combinations of the two. And we defined the one that we saw before is the classical isoquant that corresponds to the classical production function that we know it. What is the classical production function? It is a function that shows that the level of output keeps going at an increasing rate, then at a decreasing rate, then at a constant rate, then it declines as the level of the variable input increases. This is the classical production function. Okay, and as a result, the classical isoquant looks exactly like what we saw in the previous slide. But here we can have different isoquants. The most common one is this one right here. Okay, we can have this one in industry. In manufacturing, I mean, this one happens very rarely as the perfect substitute case where you can produce the level of output using x1 only or x2 only or any combinations in between. And then we defined, as usual, the slope of the indifference curve, and we said that the slope is the rate of change of x2 with respect to x1, which is what happens to x2 when x1 it changes by 1 unit, and we call it the marginal rate of substitution x1 for x2, or marginal rate of technical substitution x1 for x2. It is equal to minus delta x2 divided by delta x1, and the reason it is minus because if you increase x1 by 1 unit, you have to decrease x2 by some units in order for you to produce the same level of output. If you increase x1 and as a result you increase x2 as well, then you will move to a higher isoquant, which is not the case. It doesn't define the slope here. The slope, it means the movement, the rate of change of x2 with respect to x1 as you move along the isoquant. What happens to x2 when x1 changes by 1 unit, okay, along the same isoquant. That is the slope of the isoquant. And it has to be negative because if you want to produce the same level of output, if you increase x1 by 1 unit, you have to decrease x2 by some units. And this is how you measure the slope. And we said here, remember, the slope at point A is way higher than the slope at point E. Okay, which means that as we increase the amount of x1, the producer will be willing to sacrifice less and less units of x2 for the increase of the amounts of x1 by extra units. This is the meaning of declining slope of the isoquant. It means that at point A, I have very little x1 and a lot of x2. So I am, if in order for me to increase x1 by 1 unit, I am willing to sacrifice a lot of units of x2. But if you look at the slope right here, here I have a lot of x1 and a little of x2. Okay? A lot of x1 and a little of x2. If I here to increase x1 by 1 unit, I can only decrease x2 by very little units because I have very little of x2, and that's why the slope declines from point A all the way to point E and point F. At point F, probably the slope will be 0, which means that if I to increase x1 by 1 unit, I am not willing to reduce the amount of x2 by any units because I have very little x2. But remember, when I say that slope declines, it is negative all the way. So probably at point E, the MRS or x1 for x2 is probably minus 5. At point E is probably minus 0.5. Remember, we in economics, when we talk about the slope, it is negative slope anyway, so a negative slope of minus 5 is bigger than a negative slope of minus 0.5. And here we mentioned, without going into this hocus pocus that is mentioned right here, this is needs some student who really uses his or her mind, and at your level you're not supposed to, you're not measuring in economics anyway. So at this level you are just know that another way of expressing that slope of the isoquant is to say that it is MRS x1 for x2 is either minus delta x2 divided by delta x1 or minus MEPP x1 divided by MEPP x2, where MEPP x1 is the marginal physical product of x1 and MEPP x2 is marginal physical product of x2. And I can show you that actually here he showed that part. Actually, I don't like the way he is proving why delta x2 divided by delta x1 is equal to MEPP x1 divided by MEP x2. I can show it to you much easier than that, but actually in order to show it much easier, you have to define MEP x1. MEP x1 is equal to delta y divided by delta x1. Okay? And MEP x2 is delta y divided by delta x2. Cross multiply. Okay? And make delta y equal to 0. Then the right hand side will be equal to the left hand side, and you will reach that conclusion very easily. Okay, so just start by writing MEP x1 is equal to delta y divided by delta x1 and the cross multiply. Make delta y equal MEPP x1 multiplied by delta x1. And then MEP x2 is equal to delta y divided by delta x2. Cross multiply, it means that delta y is equal to MEP x2 multiplied by delta x2. Along the isoquant, there is no delta y. Why there is no delta y? Because delta y means a change in the level of y, change in the level of output. Along the isoquant, you have the same level of output. As a result, the delta y is equal to 0. Okay? So 0 is equal to MEPP x1 multiplied by delta x1, and the 0 is equal to MEPP x2 multiplied by delta x2, which means that MEPP x1 multiplied by delta x1 is equal to MEPP x2 multiplied by delta x2. Okay, and then do some manipulation to that equation, and you'll find that delta x2 divided by delta x1 is the same as MEP x1 divided by MEP x2. Very easy. Okay. And here we define the isocost line, and we said that the isocost line is it's a line that shows all the combinations of x1 and x2 that the individual producer can buy and will cost him the same amount of money. Okay, it is equal for the case of having two variable inputs. We have here constant, y bar, because it means that the individual producer is paying the same amount of money. Is equal to the unit price of x1 multiplied by x1 plus the unit price of x2 multiplied by x2. Where x1 and x2 in the previous equation indicates the amount both of x1 and x2 respectively. And this is how to graph it. It is how to graph any straight line. Okay, see here we assume that the level of constant, the amount of money that the individual producer will pay to obtain the two resources is $50. And we assume that the unit price of the first variable input is $5 a unit, and the unit price of the second variable input is $2.5 a unit. Okay, how to graph the equation? It will be 50 equal 5x1 plus 2.5x2. Okay, how to graph it? You need only 2 points because it's a straight line. To graph a straight line, you only need 2 points. Put x1 equal to 0 and get x2. Put x2 equal to 0 and get x1. Connect to the point, you will get that isocost line. It means that regardless of the combinations along that curve, okay, any combination will cost the individual producer $50. Okay, what is the slope of that isoquant? It is very easy. It is equal to P of x1, or the unit price of x1 divided by the unit price of x2, which is the price ratio of the two variable inputs. And that's very easy to figure it out from the graph. Just graph it and you'll find that the slope is like this. Now about sorry. At the end of the online lecture 5, remember, why did we do all that? In order to know the least cost combinations of x1 and x2 that could be used to produce the same level of output, which means that if you want to produce a constant amount of output, a certain amount of output, and you as an individual producer, you want to pay the least amount of money to do that, what is the condition for doing that? Okay, in order for you to be called technically efficient, here we call it here, remember, you can produce either you pay the least cost given the same level of output, which is what we are talking about, or another meaning for the same thing here is to produce the maximum output using or spending a given cost, remember here. Okay, given goes with maximum and the least goes with given. Okay, you never have least with maximum, never. You cannot have least cost with maximum output. It doesn't make sense. It is not logic. Okay, in that case, as usual, as we do in economics, in order for the individual producer to achieve that least cost combination of x1 and x2 that will result in producing the same level of output, then the slope of the isocost line must be equal to the slope of the isoquant, and this happens at the tangency point. The tangency point between the isoquant and isocost. At the tangency point, the slope of the isocost is equal to the slope of the isoquant. What is the slope of the isocost? It is P of x1 divided by P of x2, which is the price ratio of the two variable inputs. What is the slope of the isoquant? It is delta x2 divided by delta x1, or MPP x1 divided by MPP x2, and remember all these slopes are negative. Now we're this is what he mentioned here. This is equilibrium. Okay, this is MPP MRS of x1 and x2. It is delta x2 divided by delta x1, which is the same as MPP x1 divided by MPP x2. Okay, this is the condition right here. Okay, or this is the condition right here, or this is the condition right here. All that is the same. The three are the same, but remember, this one is not the condition. Okay, this one that I ticked right now is not the condition. This is the definition of MRS. It is either delta x2 divided by x1 or MPP x1 divided by MPP. So never write this one as a condition. Don't do that. Huh? The conditions are here. Okay, the conditions are here. Here, here, and here. Both the three say the same thing, but the first one doesn't say the same thing. The first one says that delta x2 divided by delta x1 is the same as MPP x1 divided by MPP x2. Today now we'll talk about, this was a review of what I mentioned in lecture 5, online lecture 5. Lecture 6, after that he said that suppose that at the end of lecture 5, we said that suppose that, remember we do comparative static analysis, remember we only change one variable at a time, one exogenous variable at a time. Okay, what is an exogenous variable? It is a variable which I give you its value. So we have three exogenous variables in our analysis here. We have P of x1 is equal to 5, because I told you it is equal to 5. P of x2 it is equal to 2.5. I told you it is equal to 2.5, and the amount of money in the individual producer's pocket is $50. Okay, If I change any one of those, for example, I change C, in that case I have to make px1 and px2 constant. If I change px1, then I have to leave C and the px2 constant. If I change px2, it means that I have to leave C and the px1 constant. This is called the comparative static analysis. You change only one exogenous variable at a time. When you do that, and you do that graphically, you'll see that the shape, every time the isoquant is the same, because you cannot graph the isoquant accurately. You're just going to have a smooth curve sloping downward from up to down, convex to the origin. Okay? All what you need to do is to make it tangent to whatever isoquant that you will graph. So that what will change in the graph here is the slope of the isoquant, slope of the isocost. Okay? The slope of the isocost will change when either px1 changes, or px2 changes, or C changes. Okay? When we say changes, it means that the value can go up and the value can go down for each one of them. So we have 6 cases. In each case, you will have a different isocost line. If C changes, as I said before, if C increases, then the isocost line will be parallel on this side. If C decreases, it will be parallel on this side. And then if px1 changes, okay, then you will have a rotation of the isocost line along this part right here, either this, like this, or like that. And if you have changing in px2, you will have a rotation of the budget line either like this one or like this one. Okay, along the rotation along the either horizontal axis when px1 changes, or a rotation along the vertical axis when px2 changes. And then you will have all what you need to do in that case when you graph the new isocost line is to place the isoquant that you cannot graph accurately because you are not a computer, tangent to some point along with it. That's all that you need to do graphically. Okay. End of the lecture. This is a revision of the lecture, online lecture 5. Today we'll talk about the case, the final case that we will have in our course. Okay, that talks about producing 2 outputs. Suppose that you are producing 2 outputs. Okay, now the question will be, do we need to use more than 2 variable inputs, or we can show that with more than 2 variable inputs or less than 2 variable inputs? And the answer, it doesn't matter. Here we are talking about the case of having 2 y's in that case, y1 and y2. How do you produce them? You can imagine, for the sake of simplicity, you are having 2 variable inputs, x1 and x2. Why we are saying 2? Because remember, we are using a 2-dimensional graph, a horizontal axis and a vertical axis. So in our analysis, in our graphical analysis, we never use more than 2. The number 2 is the maximum that we can show. But why? Because we can measure one variable horizontally, one variable vertically. We do not have a multi-dimensional graph, remember. So here, but here our focus is not on the number of variable inputs used. It doesn't really matter in our story here, because our focus here is on producing 2 outputs. Remember, in all our analysis before, from the beginning of the course till now, we assumed that we are producing only 1 output. So the question here will be that suppose that we are producing 2 outputs, and I want to maximize my profit. How much of the first output I should produce, and how much of the second output I should produce? The story about the number of variable inputs in this context is irrelevant, because it doesn't matter. Whether you are having infinite number of variable inputs, or you are having 1 variable input or 2, the story is the same, because you are talking about the optimality conditions, okay? Which is how much of the first output you should produce, how much of the second output you should produce if you want to maximize your profit, you individual producer. So here it says, given the set of resources available, whatever number they are, okay, what combinations of products should a firm produce to maximize profit? Okay. Remember, the firm has different amount of resources, different amount of inputs, and they can produce different. Here, enterprise, it means outputs. Okay, it means the projects, it means output. What are you going to be producing? Okay. In that case, we introduce a new concept called the production possibility curve, and sometimes they call it a production possibility frontier. Either this or that is correct. Okay, and here the example that they showed you about that production possibility curve. They said that a farmer in Alexandria, for example, has 100 faddans of land plus some other fixed inputs. Okay? Now, this issue is not important. I have 100 faddan, okay, and I have some inputs. Okay, how many is that sum? It doesn't matter in our story. Definitely, we have a minimum of one variable input and a maximum of whatever variable inputs you want, depending on, or you can imagine it as two variable inputs in addition to a number of fixed inputs. All that is the same. Doesn't change anything in our story here. Suppose that I can produce on my land here two outputs only. The first output is called the tomato, and it is denoted by Y1, and the second output is called the lettuce, and it is denoted by Y2. So I can use all my land to produce tomatoes only, or lettuce only, or any combinations of tomatoes and lettuce. In that case, we define the production possibility curve as the curve that shows all the combinations of Y1 and Y2, or tomatoes and lettuce, that I can produce given the amount of resources I have. Okay, this is the definition of the production possibility curve, or the production possibility frontier. What are all the combinations of Y1 and Y2 that I can produce given the inputs or the resources I have? And remember, in our story, I can either produce tomatoes only or lettuce only. It applies to the story. And let us look at that. He gives you here a numerical example. Okay, and he gave you here, this is our all choices. Choices A, choice B, choice C, choice D, choice E, choice F, choice G. In the first choice, okay, the farmer will produce lettuce only. If he does that, it means that all the inputs will go to lettuce. It means that he will produce zero amount of tomatoes. And as you can see when we move from up to down, okay, the second choice. Now I'm going to produce 2,000 tons of tomatoes. In that case, look at the amount of lettuce produced. Is it more than 7,500 tons or less? It has to be less. Why? Because I'm talking about what I can produce given a constant amount of resources. Okay, so if I produce more tomatoes from 0 to 2,000, then I have to produce less lettuce. And the story continues. The more tomatoes I produce, the less lettuce I produce, till I reach the last choice, where in order for me to produce that much, this is the maximum amount of tomatoes I can produce if I devote all the resources and the inputs I have to the production of tomatoes, and none of these resources will be devoted to the production of lettuce. Okay, which is the opposite of the case right here. Here I devoted in the part right here. In this part right here, I devoted all the inputs and resources to the production of lettuce, and as a result, I produced 0 tomatoes. In point G, okay, it shows the combinations of output that I can produce if I devote all the inputs or the resources to tomatoes. In that case, I can produce 12,000 tomatoes and 0 lettuce. Okay. By the way, by looking at that thing, you cannot determine what is the combination of tomatoes and lettuce that the individual producer can produce to maximize his or her profit. Why you cannot? Okay, because here we do not talk about how much production. Okay, do not tell me, for example, that I should produce 12,000 tons of tomatoes with 0 lettuce, because 12,000 is more than 7,500 here. Okay, this is not the issue, because remember, I'm talking about maximizing profit. Okay, probably the ton of lettuce is much more expensive than the ton of tomatoes. Okay, so I care about how much money I make when I produce a crop. So here the story doesn't apply. So you cannot tell which combination is the best. Okay, because you don't know the unit price of tomatoes, which is the ton price of tomatoes, and you don't know the unit price of lettuce, which is the ton price of lettuce. In order to do that, I have to give you what is P of Y1, what is P of Y2. Okay, and this is how to graph the table that we previously showed. Here I measured the tomatoes horizontally, I measured lettuce vertically, and the reason is simple, because I told you that everything that is denoted, because tomatoes is denoted by Y1, and lettuce is denoted by y2. We, as long as usually in most textbooks, when you have y1 and y2, they will tell you that whatever is denoted by a subscript 1 will be measured horizontally, and whatever is denoted by subscript 2 will be measured vertically. It is a consensus among researchers and scientists. Whatever is denoted by a subscript 1 is measured horizontally, and whatever is denoted by subscript 2 will be measured vertically. But remember, if you can measure y2 horizontally and you can measure y1 vertically. It doesn't really matter. Okay. These are the points that if you connect them, of course you will not have a smooth production possibility curve, but you will rather have a broken line production possibility curve because you have limited number of combinations. But actually in reality, this production possibility curve is a smooth curve that shows infinite number of combinations, infinite number of y1 and y2 that I can produce given the same amount of resources. Remember, for this type of curve, remember here, look at A and B. What is A and B? A indicates any combination below the production possibility curve. Okay, anything here in this area here. Anything here is possible. Why? Because I have the resources. Okay, but anything inside here, as I said, I did not use all the resources I have. Okay, anything here which is B, okay, anything in this area here is impossible. Why? Because I do not have the resources or the inputs that will allow me to produce that much. The maximum output that I can produce given the resources I have is anything on that line. Okay, so anything below that line, okay, is impossible because I don't have anything below that line is possible but not good because I did not utilize all the resources I have. Anything to the right of that line or above that line is impossible because I don't have the resources to produce it. Okay, but anything on the line is great. It means that this is the maximum output. Anything on that line shows you the maximum output that you can get from the amount of resources that you have. Okay, and these are the notes here. In order for you, as I said here, he spoiled the story for you. He said that in order for you to know which combinations of y1 and y2 that you should produce to maximize your profit, you cannot determine that just by looking at how much of y1 will go with how much of y2 that will be produced. You have to know what is the price of y1 relative to the price of y2, which is P of y1 divided by P of y2. You have to know that. Why did I say P of y1 divided by P of y2? Because I measured y1 horizontally and y2 vertically. Okay, so the price ratio in that case that is of importance is P of whatever is measured horizontally divided by P of whatever is measured vertically. And this is simple math. Okay, it doesn't need a genius. Because you will see that we will introduce now something called the ISO revenue line. Okay, the ISO revenue line is exactly like the budget line in the consumption theory and exactly like the ISO cost line in the previous case that we discussed when we used the two variable inputs that are used to produce one output only. Exactly the same. What is the ISO revenue line? Okay, the ISO revenue line is the line that shows the total revenue that the producer will get using different combinations of y1, of producing different combinations of y1 and y2. It means that whatever the combination of tomatoes and lettuce that you will produce, you will get the same revenue. Okay, the slope of that line, in that case, what will be that ISO revenue line? It will be P of y1 times plus P of y2 equal revenue, equal R. I think he called it R. Okay, in that case, the slope of that P of y1 times y1 plus P of y2 times y2 will be P of y1 divided by P of y2. Okay, so here the relative price determines how much resources I should devote to either y1 or to y2 or to both. Okay, every time that these prices change, the optimal solution will change, which means that if P of y1 or the unit price of y1 increased relative to the unit price of y2, then definitely I will produce more Y1 at the expense of less Y2. And the story continues. If P of Y1 goes down and the P of Y2 is the same, definitely I will devote more inputs to the production of Y2 compared to Y1. Okay? And the what we call it, before I go into that, we will define first of all, because remember we graphed the production possibility curve. And what is the slope of the production possibility curve? The slope of the production possibility curve is called the MRPS, Y1 for Y2. MRPS stands for marginal rate of product substitution. Remember before, the slope of the isoquant was called the marginal rate of substitution, X1 for X2. And I told you that the proper name should be marginal rate of technical substitution, X1 for X2, which is delta X2 divided by delta X1, or the rate of change of X2 with respect to X1, which is the slope of the isoquant. Here we have a production possibility curve. We are measuring Y1 horizontally, which is first output horizontally and second output vertically. And as a result, the slope of the production possibility curve will be delta Y2 divided by delta Y1. Okay? Or marginal rate of product substitution Y1 for Y2. Delta Y2 divided by, and again it is negative. Okay, as usual. Why it is negative? Very simple, common sense. If I to increase Y1 by 1 ton, I have to decrease Y2 by some tons because I have limited amount of resources. Remember, along the isoquant, I am using all the resources and all the inputs I have. So in order for me, given that I'm using all the resources that I have, if I want to increase Y1 by 1 ton, I have to decrease Y2 by some tons. Okay? So MRPS, Y1 for Y2, which is the marginal rate of product substitution, Y1 for Y2, measures the rate at which Y1 is substituted for Y2. If I to increase Y1 by 1 unit, by 1 ton, by how much I should decrease Y2? Okay, because I have limited amount of resources. Okay, and this is the slope of the production. Okay, now we define the ISO revenue line. I told you that the relative prices of Y1 and Y2 will determine how much of Y1 and Y2 I should produce if I want to maximize my profit or my revenue. In that case, because now he's talking about maximization of revenue, by the way, not profit in this story. The ISO revenue line, it means equal revenue line. Okay, it shows all the combinations of Y1 and Y2 that I can produce. Okay, and that will get me the same level of revenue. Okay, remember the prices of Y1 and Y2 are given to me. What does it mean they are given to me? They are determined in the market. Okay, the demand for Y1 and the supply for Y1 will determine the unit price of Y1, and the demand for Y2 and the supply of Y2 will determine the unit price of Y2. They are market price. I am operating in a perfectly competitive market. I have to take these prices as given. I cannot do anything to change them. I have no power because I am nobody. Look at the characteristics of the perfectly competitive market. Large numbers of buyers and sellers. The sellers, the producers cannot have any share, they cannot have any power to change the prices or to change anything. I am 1 out of million. Okay, so here if I assume that the unit price of Y1 is £1 or $1, and the unit price a unit, and P of Y2 is 5, the ISO revenue line will be R, okay, or TR, total revenue, is equal to P of Y1 multiplied by Y1 plus P of Y2 multiplied by Y2, okay, which is a linear function. Okay, you can graph it because by identifying any 2 points. Okay, you're going to say that if Y1 is equal to 0 and you get Y2, this is the first point, and then if Y2 is equal to 0, you can get Y1. Connect the 2 points, you get this ISO revenue line here. Okay, any combination of Y1 and Y2, remember here I'm measuring Y1 horizontally and Y2 vertically. Any combination of Y1 and Y2, including production of only Y1 or production of only Y2, will result in the producer receiving 30,000 pounds. Okay, given the numbers I gave you here, that the unit price of Y1 is equal to 1 and the unit price of Y2 is equal to 5, and the numbers that I showed you in the combinations in the previous table. Too bad when you make a video you cannot go back, you cannot go backward, you can only go forward. Now I wanted to know what is the optimal combinations of Y1 and Y2 that if I to produce will get me the maximum revenue. Okay, the usual story. We have a male and we have a female. Get a sheikh or get a priest to make them get married, which means that when the ISO revenue line is tangent to the ISO to the production possibility curve, the point of tangency will define that optimal. It will define the amount of Y1 and Y2 that if you produce, you will maximize your revenue. Okay, because in our story here, we are talking about maximization of total revenue. Okay, why? Because the costs are not included here. It's not shown for simplicity. Okay, in reality, the situation is a little more complicated than what I'm talking about right here. We are talking about here what is the amount of Y1 and Y2 that if I produce, I will maximize my revenue in that case. Okay, because usually when revenues goes up, usually profits will go up. Usually, not necessarily, of course. Okay. So these are the combinations of Y1 and Y2 that will result in the producer obtaining 30,000 pounds. Okay, and the slope of that is simple. We know that the slope of that is similar if you just have some intelligence and if you are using your mind, we'll see that if I am measuring Y1 horizontally, Y2 vertically, then the slope of that line will be P of Y1, P of whatever is measured horizontally, divided by P of whatever is measured vertically. So in that case, the slope of the ISO revenue line will be 1 divided by 5, okay? Or P of Y1. Here it says rings a bell because this is a repetition of every time. It means that didn't you realize something? Didn't you realize that if you studied consumption theory, you will know that it is the unit price of the first product you consumed divided by the unit price of the second product you consume? Or if you are talking about the case that we just covered in that same chapter, okay, which is chapter 5, which is the case of having two variable inputs producing an output. When we measured the first variable input horizontally, the second variable input vertically, what was the slope of the ISO cost line? It was P of X1 divided by P of X2. The price of whatever is measured horizontally divided by the price of whatever is measured vertically. So likewise, I'm measuring Y1 horizontally, Y2 vertically. In that case, the slope of the ISO revenue line will be P of Y1 divided by P of. Okay. So what is the optimal thing here? Okay. Revenues are maximized at the tangency point between production possibility curve and the ISO revenue line, at the tangency, at the equilibrium point, okay, or at the best combinations of Y1 and Y2 that will maximize my revenue. The slope of the ISO revenue line, which is P of Y1 divided by P of Y2, okay, must be equal to the slope of the production possibility curve, which is delta Y2 divided by delta Y1. Okay, if I do that, okay, then the shown right here, if I do that, this is the amount of Y1 measured horizontally, amount of Y2 measured vertically, okay. This is the production possibility curve, this is the ISO revenue line at the point of tangency, okay. It is called the equilibrium point, it is called the best point, it's called the most efficient point, okay. At this point, if I produce Y1 star and Y2 star, I will maximize my revenue, okay, because at this point of tangency, the slope of the production possibility curve, which is delta Y2 divided by delta Y1, is equal to the slope of the ISO revenue line, which is P of Y1 divided by P of Y2. If I do that, I will maximize my revenue. And remember, the two slopes are negative anyway. The negative slope here indicates that in order for you to increase Y1 by 1 unit, Y2 has to decrease by some units. That's why you have negative slopes all the way. Okay? And the same thing for the ISO revenue line. If you increase the amount of Y1 by some units, then you have to decrease the amount of Y2 by some units in order for you to achieve the same level of revenue. And as you can see, okay, here the story is very similar to what we mentioned before, but what it changes here is what is the wording. The wording changes, but the story is the same about the optimal condition that we should do. Here we're talking about having two outputs, and here I tell you that if you want to maximize your revenue, Okay, then produce y1 star and y2 star, because if you do that, uh, 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 you will maximize your revenue, because the slope of the production possibility curve is equal to the slope of the ISO revenue line. And this is the end of the class, given that you guys are not yet specialized in economics. I hope that the lecture was of benefit, and I hope to receive interaction from you, not only about this lecture, but about all what the lectures that I uploaded for you. I uploaded for you so far 6 online lectures. Okay, hope everybody is good. Stay home, stay safe. Bye bye.